I'm Ballinan, your news anchor for this day, serving you the hottest, latest news for this hour. Let me introduce you the other three reporters, Mr. Eushua Mondragon, Mr. Gervacio, and Mr. Edward Odita. This is the #1 broadcasting channel nationwide. This is 1C News Channel.
Thank you, Mary Charm Ballinan. So we are here at Eastern Samar live, and I am here to report to you about center frequency. In order to get the center frequency, we have a formula of Fc is equals to square root of minimum times maximum. For the wavelength, if we want to get the wavelength, we need to divide lambda over 2. The value of f of the center frequency divided by 2. That would be all for
Good day, I'm reporter Gervacio, and I'm going to talk about on how to find the length of driven element. First is we need to talk about the formula. The formula of length of driven element is lambda over 2. Then we can find the final answer for our length of driven element. In our equation, we divided the wavelength into 2. So the length of driven element is 1.58113883 meters. Next is on how to find the length of director. On finding the length of director is we need to minus it to 5%. So 0.95 times 1.58113883 meters. The final answer or the length of our director is 1.5020818889 meters.
Hello, my name is Eushua Marlon R. Mondragon. I'm from Group 4. Our frequency is 30 to 300 MHz and 1 director. I'm gonna be calculating our length of reflector and the space between the reflector and the driven element. First, we need to calculate our length of reflector. To get our length of reflector, we must get our center of frequency, which is 1.1511 to 3883 meters. Then we will add about 5% of that, and that will be 1.6601957772 meters. Next is the space between the reflector and the driven element. First, we need to get our wavelength, which is 3.1622776 meters. And we will times about that with 0.15, and we will get a 0.4743 and 41649 meters. I'm Eushua Marlon R. Mondragon from Group 4. Thank you for listening.
Next is the spacing from the driven element to the director. The formula of this one is 0.10 times the wavelength, which is 3.16227766. The final answer is 0.316227766 meters. The last one is the length of the boom. The formula of this one is the spacing from reflector to driven element added with the spacing of the driven element to the director plus 1 inch times 2. The value of this one is 0.4734169 added to 0.316227766 plus 1 times 1 inch, which is 0.0254 times 2. The final answer of the length of the boom is 0.8413694115.